some algorithms on graphs. What we're going to start looking at are algorithms for finding the minimum spanning tree of a graph using two different algorithms. One of them's called Kruskal's, one's called Prim's. They do the same thing, they just do it in different ways. Okay, you need to know the difference between the two. I'm not going to do this starter, but this is the sort of thing that you are, a sort of problem that might be applied to. So this example is representing a computer network, and the numbers on the graph represent the length of the cable. Okay, so all the computers are linked up to different ones. What you're wanting to do is have a minimum spanning tree so that all of these computers are still linked up, but you don't have to put all of these cables in. Okay. And that's what Prim's and Kruskal's algorithms do. They find minimum spanning tree for a network like this. Okay. This is an example. These lines in green here are an example of a minimum spanning tree. So this is all of the nodes are linked up. You can get from any node to any other node, but there are no cycles in it. Remember, a cycle is where you can kind of go around. So like you couldn't put BC in here because it would make a cycle around BCD. But all of these nodes are still linked. Okay. So I think in your pack there is space for a definition. This is a definition of a spanning tree. So, or a minimum spanning tree. Sorry, a minimum spanning tree is a spanning tree such that the total length of it is as small as possible. Hence the limit. Jot that down in your pack, please. And we've talked a little bit about real life applications. I'll give you a couple of things you can put in there. So you don't need to copy all of this. Please don't copy all of this. But you can put in like TV cables. You can put in computer networks. So the first one of these we're going to look at is Kruskal's algorithm. Kruskal's algorithm, invented by Mr. Kruskal. You can write this sentence in here. So the Kruskal's algorithm finds the shortest way to link all the vertices in a system. You choose which of those three words you want. Quickest, shortest, cheapest. Depends what context you're doing it in, really. You've got to connect up all of the vertices, but you obviously don't necessarily use all of the edges in it. Okay, so in your pack, it does have a step-by-step list of how you do the algorithm. I'm not really going to talk through this, so you can read through it yourself. I think it makes more sense to actually do it. But it is, again, just a process for you to learn. So for Kruskal's algorithm, the first step, which is in your pack, is you've got to list all of the arcs in ascending order of weight. Okay. Weight is just a number. Okay, so smallest to biggest. You don't have to use a sorting algorithm to do that unless it tells you in the question. Occasionally, they will get you to do like bubble sorting. But for this one, you don't have to. So first thing you've got to do, look at your network, which you've got this little triangle one down here, and just write down in ascending order the list of the. So the smallest one is FE, which is 8. Then check along here. So the next one, you've got FD for 10. Doesn't matter whether you put FD or DF. It's entirely up to you. And just keep building that up. Next, you've got a choice. So you've got 2 12s. It doesn't matter which order you put them in. So you can put B, D, and DE in any order. Next, you've got BC, that's for 13. Then you've got CE for 14. CD is your 15. And then your 19 and your 20, A, B, and 80. Jot those down. Now make sure you're careful with that. It's really easy to make little mistakes. Miss them off. You don't want to cross them off on your graph as you're doing this or whatever. And this is an important thing about Kruskal. So Kruskal is concerned with the arcs on a graph, with the lines. Okay, so you listing the arcs, and then you're going to build up your minimum spanning tree just by adding these on one at a time. Okay. So the step 2, it says select the arc of least weight and start the tree. And then step 3, consider the next arc of least weight. You're building it up using the smallest ones. As long as you can add it on and it doesn't form a cycle, then you add it onto your tree. And what I would recommend that you do is you've got to list the arcs in the order that you consider them. So list them as you put them on. I would also be drawing it as you go along, either tracing along the existing one or drawing a new one as you go along, just so you can see which ones form cycles and stuff. And then state the weight of your tree. You're just going to add them up at the end. So first one we're going to add on, if you want to jot some nodes in your pack so you can draw that. Copy that in. First one we're going to add on is the shortest one, which is FE. So we're going to join FE together. Usually what we do is we tick and cross it as you go along for which ones you've added on. So tick FE, that's fine. Next one we add FD. FD doesn't form a cycle, so we can add that one on. So we tick it and we add it on to our diagram as we go along. Next one's DB. DB is fine. It doesn't form a cycle, doesn't join these up. So DB is fine. We add that one on. Oh, DE is the first one that we come across a problem. DE, if we added DE in here, it would form a cycle. So we can't add DE on. So put a cross to indicate that you haven't chosen that one, or you can crop it out or whatever. And we just keep going down the list. So BC is fine. We can join B and C up. The 13. We just need a way to join A up now, so either to D or to B. DC we can't add on because it makes a cycle between B, D, C. But AB is fine. AB we can add on to join up A to our minimum spanning tree, and then we're done. All of the nodes are joined up together. DA obviously would make a cycle around here, so we reject that. Those ones that we've ticked there, they are minimum spanning tree. It says list the arcs in the order that you consider them. The solution hasn't listed them, but I would write them out. I'd write FE, FD, DB, and so on. And state the weight of your tree. So add up the ones you've got ticks next to, which gives you 6. It's a big one. You've got to be careful with this. It's really easy to miss things off or miss out that you've actually made a massive cycle and things like that. So be really careful. First thing, you've got to list these arcs in ascending order. So just make sure you go through them carefully. You might want to tick them all off. I'm not going to go through that because you know how to put in order. Remember, when you've got arcs that are the same weight and you've got quite a lot of those, it doesn't actually matter which order you list them in these. It will end up working itself out anyway. Occasionally you might have a choice to make it, doesn't really matter. To draw the minimum spanning tree, I would copy out what the position of the nodes and then fill these in as you go along. So very, very quickly, I don't want to spend ages on this, but going down here, you can add GH on, FJ on. Notice that this is building up in a disconnected fashion. So you can add random arcs that are not connected at the end. Halfway, but they will end up connected at the end. GD is fine. DH we can't add on. Thank you. DH you can't add on because you will make a cycle down there between DG and H. Carry on then. BC is fine. BE is fine. EI is fine. None of these are making cycles. You can't go around these. HJ is okay. It doesn't make a cycle there yet. It's not all joined up. EF is also okay. That joins up those two bits there. Still no cycles. And now we're starting to get into the territory where you're going to cross everything off. So CG will make a cycle, can't put that on. IJ will make a cycle, can't put that on. BF's a cycle. AB is not a cycle. It joins up A there. And now all of our nodes are joined up. You know that you're done. You're not going to add any more on. You can check as you go along, but all of these down here we're going to reject. Because all of our nodes are joined up already. It asks you in the question, it just says find the minimum spanning tree and state its weight. I would list the arcs in the order that you've selected them, so it's literally just going down here and writing G, H, F, G, and so on. And then the total weight of this, add up those, you should have got 90, which are quite a lot. Okay. Any questions on that one? So the part B as well, so if you haven't looked at part B yet, have a read of it. They do ask you things like this in exams. There will be, like, part A of a question will be do critical algorithm, but then part B will be Potentially something weird, they change something about the network or whatever and asking you how it affects it. This one says they decide that the road between Golka and Honley, so it's implied in the question that's between G and H. That's this one. It is too steep to worth gritting. So you're going to take out GH. It asks you what effect does this have on the minimum spanning? Any thoughts on that one? Yeah.
Well, you remove the 6.
Yeah.
And then you've got to see what's the shortest path to still get to J. It's 10.
Yeah, to H, yeah. Yep, good. Shortest one to still join up H has to be adding in DH. That's fine once GH is gone. Yeah, so you'll be taking off 6, you'll be adding 10 on, it'll add 4 onto your minimum spanning tree. So your total weight will change from 9 to 9. It's difficult to prepare for those because they ask all sorts of random things, but think carefully about it and you should